x squared functions. Okay, they will have x squared in the equation. So it may be, like, look at number 1. 2x squared plus 4x minus 3. Okay, that is a quadratic function. The requirement for it to be a quadratic is that it has x squared. The general form, so if you look up here, okay, right here, this is our general form. Okay, ax squared plus bx plus c is called a quadratic function. Does anybody know the shape, what we call the shape of a quadratic function?
Well.
Hey, yeah, it's a parabola. Look at that. It's right there. I gave it to you. Okay?
Oh, wow.
A quadratic function is in the shape of a parabola. Everybody say parabola.
Parabola.
Okay. It's a weird word. It's a weird word, but it just looks like this. Okay? A parabola looks like this, or it can point downward. Okay? You've probably seen them before.
Parabola.
Yeah. It has the arrows on it, so it goes to infinity. We talked about that when we did domain and range. You saw them. Yeah, you saw them on Friday. Duh. Okay. Okay. The key points of a graph. Okay, we call it key features of a graph. X-intercepts, Y-intercepts, and the vertex. Everybody say vertex.
Vertex.
Say Y-intercept.
Y-intercept.
Say X-intercept.
X-intercept.
Beautiful. Those are the 3 main things that we will look for a quadratic. Okay? And Desmos is going to help us find those. I'm not going to ask you to find them just by looking at the equation. Okay? You get to look at our BF. Yeah, on BFM. Okay. Okay, so what I want you to do, go in Desmos. Okay, put in number 1 into Desmos. 2x squared plus 4x minus 3.
Oh, crap. That's in the word.
Did I put this in right? 2x squared plus 4x.
4x minus.
Ooh, it's a red line.
And then the other thing. Why are the lines different colors? They like change colors.
It's just like if you put in multiple lines, it would do a different color for each line. Okay, do we have it in there?
Boyfriend, man, lover.
Oh my. Okay, let's not go there.
BFNL.
Oh Lord. Okay, so take a look at your notes. We're going to be writing down the vertex, the y-intercept, the x-intercept, and then we're going to talk about domain and range as well. Those are called our key features of our graph. Okay, so let's look at our graph here. What am I doing? Here we go. Okay, our vertex is right here, and remember on Desmos you can tap. Okay, so if you just tap that vertex, it'll tell you the coordinate point. -1, -5.
Oh, you typed it wrong, so I typed it wrong.
Me? Yeah, I typed it in wrong originally.
Yeah, which
That was my fault. Yeah. That was totally my fault. Okay, so our vertex should be -1, -5. Same thing with the vertex. You can tap on the x-intercepts and it'll tell you what they are. Go ahead and write those down on your notes.
Oh, geez.
Huh?
We have to plug
We will. Yeah. I write them all down and then I plot them. But you can do it as you go if you want to.
And it was, it is.
So -2.581 and 0.581.
It's fugly. Everybody,
Oh, that was our x-intercepts.
yeah.
Go look at that. I can just move them there.
Wait, before you just do that.
Yep, I did. Okay, same thing with your y-intercept. Tap on that y-axis, right where that crosses that y-axis. There's your y-intercept, 0, -3. Okay, so you can just easily tap on those and write those down. Okay, once you get those 3 items written down, don't worry about that domain and range. I want you to draw it. Okay, go ahead and draw it first. We'll do the domain and range here in a second. Okay, and those x-intercepts, you're going to kind of have to roughly draw those in where they should be. Okay, and your graph's not going to be perfect, but you need to have those 4 points in there. The 2 x-intercepts, the y-intercept, and the vertex. You should always have those.
It's pretty swell. It's pretty swell.
Okay, domain. Anybody remember the domain of a quadratic?
It's something in the between each.
Our x's? Yep. So our leftmost x to our rightmost x. Anybody remember from Friday?
Yes.
Yes.
Wait, what?
Negative
Why?
infinity to infinity. Why is it negative infinity to infinity?
So they
Oh,
don't
you just
go
want to keep on going.
Yes, our arrow, even though it looks like it's just going straight up, it's actually going like this. Okay, and it's just going to keep going to the left. Same thing over here. It's going to keep going to the right. So our domain, let's hear me when I say this. Our domain for all parabolas, all quadratic functions, always negative infinity to infinity. Every single time. Okay? Because you're always going to have those arrows. So this will always be negative infinity to infinity. Okay? And I like to write it interval notation, okay? But we need to know how to write it both ways. So I can also write it like this. Yeah? Okay? I don't care which way you write. Oh, sorry, we don't put those lines up.
Would you get points taken off if you accidentally write the lines because there's no?
Yes, because remember we can't really pinpoint infinity, so we can't put the lines there because lines mean equal to.
Would it count as wrong because
Yes. So be careful on that. All right, our range.
-5?
Okay, so our range is our y values. Everybody say range.
Range.
Say y.
Y.
Okay, so think about y the range. Okay, y values bottom to top. What's our least y value? Lowest y value? -5. Okay. Oops. I'm gonna write both versions here. So -5, and where does it end? Infinity. Okay. I put a bracket around my -5. Why?
Because it's a negative.
Not because it's a negative.
Wait, what?
Because it's not infinity.
Is -5 included on our graph? Is there a point that has a y value of -5?
Yeah.
Yes. That's why we include that. Okay. So same thing. If you were to put it in this the set notation, you would put the line underneath. Okay. So the line and the bracket mean the same thing. Yes. We remember that. So imagine doing this without Desmos.
Probably can't.
It would be, it's awful. Okay, so Desmos is amazing. All right, and it's free. Well, I'm sorry. EFN is amazing. Okay, I'm not gonna remember to say
It's
that.
okay, I
just to
don't
be
care. I'm
honest.
just like, we're just gonna go with it, and I'm just gonna end up saying boyfriend man.
All right, go ahead and put number 2 into Desmos. Okay, I would probably clear this out. That way you don't have to see the old one. Okay, what do you notice about this one? It's upside down. Huh?
Red.
It's negative. Okay.
It's a blue line. It's the other way.
Okay. So the biggest thing is that it's pointing the other direction. Okay. Now, Elena just said it's negative. Look at the start of number 1. It was a positive 2x squared. Do you see it?
Yeah.
I don't think you're with me. I need you with me here. Okay, do you see the positive 2x squared on number 1 at the very beginning of that equation?
Yeah.
Look at number 2. It starts with a what?
Negative.
And it points down. Weird. Very weird. Anyway, this one's pointing down. We'll see if that's normal. So, go ahead and record your y-intercept, record your x-intercept. But wait a second, we only have one x-intercept.
Oh my
Okay?
god.
That's another thing. Sometimes you'll have 2 x-intercepts, sometimes you'll have 1. Surprise, sometimes you'll have none. Okay? And we're going to see an example of that. Okay? It can happen. So go ahead and record these. So we have 2, 0, and 0, -4. Was the vertex 2, 0?
Yeah.
No. Yeah. Yeah. And the x-intercept was 2, 0, right?
Yeah.
Okay. So those end up matching. So if that vertex sits on that x-axis, you're only going to have one x-intercept. So this one you kind of have to roughly draw what that would look like on that right hand side. Kind of weird. Okay, what's our domain? Hmm? Okay, and what's our range?
0 to -2.
Bottom to top. So this is going towards negative infinity, and it comes up and it stops at the y value of 0. Okay, a lot of times people want to put 2, but that's the x value. Remember range is y. Okay, so the y value there is 0. Okay, I'm going to throw something else at you. You ready?
No. Wait. Okay.
Okay, if we say that, would you agree with me that the range, okay, focus on range, that the range is all y values less than 0?
How does it make sense? Yeah.
All of the range, or the y values, of our graph are less than 0.
Yes.
Yeah.
Okay, because it's 0
Yes.
and
So
under,
that's
right?
graph.
So another way I can say this is y is less than or equal to 0. Okay, so you can write the range either way. I want us to transition to knowing that these are the same exact thing. Okay. Yes? You with me on that?
Yes.
Okay. Yes, please.
Yeah. Oh.
Totally fine. But if I give you a multiple choice question and it had the other one, you would need to know. Do you know what I mean?
Yeah.
Okay, we're going to start to be versatile here. Okay, we feeling okay about this? All right, are you already on number 3?
Yeah.
I knew you were. Okay, go ahead and put in number 3 to Desmos.
Oh, this is this one the case.
Oh, no.
Ooh, look at this.
Wait.
Remember how I told you that it's not going to always touch the x-axis?
Yeah.
Here's example A. Okay, right here, what is this 1, -2?
Vertex.
That is our vertex. Okay, what's this guy right here?
Yeah. Y-intercept.
Do we have x-intercepts?
Not that I can
No.
see.
So on that x-intercept line, you're just going to write none. Okay, you're going to write
I'm
none.
right. No. No, it's fine. Okay. That looks really. My handwriting is really bad. Whoa.
Okay, now take a look at our graphs. Which 2 graphs are alike between numbers 1, 2, and 3?
2 and 3.
2 and 3. What do you notice is the same about 2 and 3?
They're both negative.
They both have negative at the very beginning of the equation. So when the equation is negative to start, it's going to point down. Yes?
Yes.
Do you see it?
Yep.
Are you with me? Are you
Yeah.
live?
Yes.
Okay. So when the equation is negative, when that x squared term is negative, the graph is going to point down. When it's positive, it's going to point up. Okay? You're going to start to notice a lot of patterns that happen with quadratics, and it will really, really help you when it comes to taking quizzes, tests, things like that. Because you're like, oh yeah, I remember this about that. It'll help you. Okay? Domain. What's our domain?
Negative.
Yep, negative infinity to infinity. Our range.
Y is less than -2. Less than or equal to -2.
Okay, so we could go here, right? -2. Yes? Or we would just say y is less than or equal to -2. Okay? And I really want to try to get you to that latter answer. Okay, the y is less than or equal
Isn't it a 1, not 2? Why is this the negative infinity? Isn't it a 1?
to range, y value. I think, yeah, y value is -2. But if we were doing x value, it would be 1. But since it's range, yeah. Okay, one more, except for we're not going to draw the graph of it, because you should be able to pick out the key features without having to draw it. So we're still going to use Desmos, but now we don't have to draw the graph. Okay, we can just use the Desmos here. So go ahead and put your equation into Desmos for number 4. Group, what did you notice? I don't know if you noticed this or not. I don't know if I should frame this question that right away. But did I put y equals in my Desmos? No? Okay. You're going to notice that they're written with y equals. Do not type that into Desmos, because Desmos is not as smart as you are. Okay? It will get confused. So just type in everything after the equal sign. Does that make sense? Okay.
What would it do? Like, would it make it a line?
Sometimes it'll graph it just fine, and sometimes things will look so wacky, and I'm like, where did that even come from? So that's why I just tell everybody just everything after the equal. Okay. All right. So our vertex. Oops. Maybe. Our vertex is 3. I'll get right to you. Our vertex is 313. Do you agree? Did you get that on your page? Yeah. Or on your, okay. And then our x-intercepts are negative 0.606, and then 6.06 and 0.4 for our y-intercept. Yep. Okay, let me fill mine in up here. Okay. Have I ever written my x or y intercept as just a number today? No. I've always put it as a coordinate point. Okay? And we're going to get into practice of doing that. Why don't you write those as coordinate points? Our domain. What's our domain? Okay, and you can look at Desmos for it. You don't need to just know it based on what's written up here. Okay, you can look at Desmos for it. What's our domain? Yep, that's a given, right? We always know that. Range. What's our range?
Negative infinity. Y is less than or equal to 13.
Y is less than or equal to positive 13. Okay? If we look, okay, at our graph, let me scroll out here. Maybe. Okay, if we look at our graph, okay, our arrows are pointing down. So it's negative infinity all the way up to 13. Or we can say y values are all less than or equal to 13. So that's why we write it that way. Y is less than or equal to 13. Yes?
Yeah.
Okay, on the back, those are all on your own. Just use Desmos exactly like we were doing. Fill those in. Okay? I have my answer key up here so you can check yourself.
Wait, you want us to do the graph thing too?
Yes, yes.